Good morning, everyone. It's Meredith, and this week we're talking about waterborne pathogens and water quality. And you get brownie points if you know where this picture came from. Hopefully, some of you do. It was actually one of Kevin Costner's better movies, in my opinion. Okay, so we're going to look at a few world maps to start with, because as you probably know, water is a global resource. So the water that we have here in Portland, Oregon, or wherever you live for that matter, has traveled, chances are, throughout the hydrologic cycle, and so it's something that we all potentially contaminate and all of us use, right? So this map goes back in time to 1980 and up through 2015, which in 1980 that was a long time ago, but this is actually 2015 is probably closer to what it is now. But this is looking at water availability in 1,000 cubic meters per year per capita. So as you can see, the dark green is where you have a good amount of water availability, very high, more than 20,000 cubic meters per year per capita. Even in 1980, you can see the United States was in the high range, but they're estimating by next year actually that it will be more in the average range. We go from light green to yellow by next year. The more critical category is the red, obviously, and you can see over time that countries in the African continent, in the Middle East, in Asia, they tend to go from yellow to orange and in some cases to red, like especially if you're looking at the 2015 map, you can see that there's pretty much the entirety of India and more parts of the Middle East have gone to catastrophically low categories. This is another global map, although a little bit outdated at this point, but talking also about drinking water sources, and the thing that goes hand in hand with that is sanitation. You can have some of the best water in the world, but if you have no place to put your sewage or to treat your sewage, perhaps more importantly, your water source is likely contaminated. And this leads to rampant disease, which is one of the things we're going to talk about in lab this week. So yeah, so pretty much the entirety of Africa, the Middle East, Asia, not ideal sanitation conditions. And this final map is showing a different aspect of water quality, which is water stress. And this is something we're going to look at a little bit more. I believe next week we're going to watch Blue Gold, which is a great documentary on water resources and water scarcity. But in this map, you're looking at exploitation of water resources, and unlike in previous maps, you can actually see in the United States anyway, according to this research in 2004, that large parts of the United States are under pretty severe water stress. All of the desert parts, obviously, California, Texas, New Mexico, going all through Central America, and not surprisingly, a lot of that has to do with our use of water for agriculture. So to get back to kind of what we're focusing on this week, we're talking about waterborne pathogens. And pathogens are essentially any kind of microorganism that causes disease. And so a microorganism just refers to a single-celled organism, so a bacteria, a virus, things like that. In the United States, the primary problem with pathogens is from fecal matter, from sewage discharge. And in Portland, Oregon, anyway, we've had kind of a history of overflow from our combined sewage and stormwater treatment. And so they began this long, many-year, multi-million-dollar process of building the big pipe, as they call it. which would prevent these overflows from happening during a storm event. But typically, what would happen is we get a huge storm that would, overburden the pipes, and raw, untreated sewage would go into the Willamette River. This is also this has been reduced significantly, thankfully, by the big pipe. But another serious problem is areas near cattle ranches, feedlots, any place that there are cows, generally speaking, farm animals, and you have runoff from those areas, you're going to have water quality and potential pathogen issues in your drinking water. So one of the ways that the people that should be in charge of water quality, like the EPA, and in Oregon, the Oregon Department of Environmental Quality, they regularly take total coliform samples of the water, of drinking water. And so total coliform is a way of measuring how many essentially fecal bacteria might be in the water. And so there's a maximum that can't be exceeded for human health. And so the Environmental Protection Agency in the United States, that's one of the primary goals or missions, you could say, of the EPA is ensuring that there is safe drinking water for the citizens of the United States. So that responsibility is then delegated to each of the states individually. So DEQ in Oregon is responsible for conducting these total coliform counts. And in certain places, like if you were to go out to Tillamook, Oregon, where there are very many cattle and lots of runoff in that watershed, they often have high coliform counts because of the cattle. So a few of the pathogens of concern include cholera, which, if you were watching the news at all in 2010 and you heard about the earthquake in Haiti, that was actually followed by one of the largest cholera outbreaks in history, in recorded history. Over, I think, 400,000 cases of cholera occurred since that earthquake in 2010. And it's a waterborne disease. So once it gets into the system, it's really hard to eradicate, and cholera is quite lethal. I think they had, I don't know, close to 10,000 deaths just from this one event. Botulism is another one, typhoid, fever, hepatitis, dysentery, which is a huge problem in many developing countries, and probably one of the leading cause of deaths in infants and children in third world countries. Cryptosporidiosis, I didn't pronounce that right, but that's a protozoa that can be in water. Polio and giardia. And giardia you actually might be more familiar with if you go camping. They always advise you to not drink from mountain streams because of giardia. So this is just another map showing countries with cholera cases, and as you can see, it's primarily developing countries with poor water sanitation. So, and this is just cholera, right? This isn't any of the other pathogens we just looked at. And then this is just a kind of a startling graphic from water.org, which I highly recommend checking out sometime. It's got a lot of really good information. Some of it can be a little alarming, but try to keep it in context. But water-related disease is a significant problem. And the water.org people have researched that 3.4 million people die every year from waterborne disease. And that is a population equivalent to almost the entire city of Los Angeles. So that's a lot of people. So it's not just pathogens that can affect human health in water, right? There are other things that go into water that thankfully we can look for and ideally track before people drink it, unless you live in West Virginia and you get that delightful chemical spill. Um, but other things include phosphates, nitrates, and nitrites, and those are things that you would typically find in fertilizer. So if you live near a farm, there's a storm, any kind of runoff can run into potable water sources and contribute those things to your drinking water. Heavy metals, so this can happen just through geology, like if there happens to be, say in my case, my metal that I study is mercury. If there's a lot of cinnabar rock in the local geology, you're likely to have higher mercury concentrations than you should for healthy drinking water. Obviously, things like cadmium and lead, those can be released through factory use and inappropriate disposal of wastes. Other things, I don't know if any of you have seen or read the book was called Civil Action. It was a really great book and talked about uh, essentially people pre, I guess, pre heavy enforcement of NEPA, the National Environmental Policy Act, people dumping toxic pollutants into ditches, and then all of a sudden, huge cancer cluster in this kind of suburb of Boston, Massachusetts happened. So, lots of things can get into water. A lot of industries are still paying the price for contaminating water sources and groundwater. So, one of the things that we are going to do this week in the water quality workshop is look at different ways to treat water that can potentially have high coliform counts. And so, one of the most basic methods and probably most widely used methods is to boil water. We're also going to look at filtration um, and then tablets, which is basically a form of chlorine powder, and you will all be getting some of this powder in the package that I ship out to you hopefully tomorrow. And then also there are things that we won't be experimenting with in this workshop, but other uses around the world include UV radiation for water treatment, and also the use of a ceramic pot that kind of pulls contaminants, potential contaminants out of the water through, I believe, through osmosis. So boiling water is the most basic method, and this works for a lot of things like pathogens, but obviously wouldn't work for something like metal. In fact, the recent water spill, chemical spill in West Virginia had that caveat when they were warning the local citizens not to drink the water, because people think that if you boil something you can get rid of everything, but that's not true. If you have a kind of a persistent organic pollutant like TCE, trichloroethylene, you can boil it and it's still going to be toxic in your water. So boiling water really only works for pathogens. And again, if you have a clean pan, that makes life easier, but if you're you have to think about what you're cleaning your pans with and your cooking utensils. Another method is filtration. There's something called the life straw. That's this thing in red right here. And that's more for like personal individual use and for camping and things like that. Again, it's not an ideal water treatment situation, but it's kind of an emergency thing. There's also purifying tablets and powder. That's what we're going to send you this week, and you're going to experiment with and see how that affects your coliform counts. Again, this is also kind of an emergency situation. Your water isn't going to taste really good. It's going to taste chlorine-y, not surprisingly, but hopefully it will kill the stuff that could potentially kill you. So that is our water quality lecture, and I want you to go ahead and look in the week 6 folder, and we will talk about this week's assignment, which is looking at an individual country and one of their water problems and kind of researching that country's water situation in depth, and it can even be a particular region. Say you want to look at, Chile and um, a certain water crisis that's going on in a part of Chile, that's fine. So go to the week 6 folder and check that out. And as always, email me with any questions. Thanks so much.